How are we all doing? Yeah? Quick show of hands. I'll just wait where everybody counts. If that doesn't look odd, then there's something odd with you. Is this your first conference? Show of hands. How are you liking it so far? Yeah? If you're going to go to a conference, you might as well go to a conference, and you might as well do it in Vegas. Because the downtime's quite good, isn't it? That 8:30 start, that's a killer, isn't it? Okay, so second question, who's seen one of my talks before? Thank you. Who's here because you told by somebody that you have to see me talk? Okay. So you're the ones I've got to, convince that the thing was true. The rest of you couldn't get into the other sessions? You're just killing time before Dev's on stage, yeah? Okay. That's fine, I don't mind. You're in here, it all counts. So a couple of logistics to get out of the way. So everybody's got the TC17 app, so get it out now and just do the 5-star rating now. Get it done and out of the way, because at the end of the talk, you're going to be rushing off, so let's just take a minute, do it now, okay? But don't do it for me, okay?
Please give my daddy 5 stars.
Look at them. Look at the faces. It's been a hard year, and all they're going to get is conference swag for Christmas. All right? Make them happy. Let Daddy come to more of these things. I only get to do it with 5-star reviews, then they can get swag. Otherwise, it's going to be a cold, disappointing Christmas for them. So, good afternoon, everybody. Thank you for coming along. It really means a lot when so many of you choose this session out of the 100 and however many you could have gone to see instead. So for those of you who don't know me, my day job, well, I'm Matt Francis, obviously you know that because you saw that on the title. I work here, which is the Wellcome Trust Sanger Institute, which is a genome sequencing centre nestled in the heart of the Cambridgeshire countryside. This is my office here, and I'm the Tableau guy. So I do everything for Tableau. I do Tableau server, I do Tableau desktop, I run Tableau training. Anything that's got Tableau in it, I do it. So we work at the Institute with DNA. And our primary purpose is to decode all the information in DNA to improve human health. So that involves a little bit of biology. We add a little bit of chemistry and some big, powerful sequencing machines. Each one of these machines here is about $500,000. So we've got a fleet of these, and we all take DNA, smash it to pieces, and get the individual genetic sequence for all of these DNA samples. So there's a lot of engineering goes into that, and then we have to run it through computers to analyze it, a little bit of electronics, and that produces data. Lots and lots of data. So the Sanger was set up as part of the Human Genome Project. There we go. Which was a 10-year project. It cost $3 billion, 13 years actually, to sequence the instructions to build the human being. Okay? 10 years, 13 years, $3 billion to produce the sequence for one single person. And that's a lot of information. So the entire genetic code in every single one of you is 3 billion bases. So that's A, C, G, or T in a very specific order that's unique to you and you and you and you and you. Okay? Unless you've got a twin, in which case it's going to be the same. And this was all done on these instruments here. So this is one of the next generation sequencers. We've got a big fleet of these. And this can now produce 300 times, 300 genomes in about 5 days. So that's the progress we've made over the last decade or so. So this allows us to do very interesting things with genetics and data. 300 genomes, that's an awful lot of data. So how do we track this in the lab? What's the process of doing it? Well, we have these barcodes, and we barcode everything. So all of the instruments are barcoded, all of the DNA plates are barcoded, all the equipment's barcoded, all of the people are barcoded. They don't enjoy that bit, but they've got to have a tattoo sometimes, so we just barcode them as well. And whenever they do anything in the lab, they scan themselves, they scan the barcode, they scan the machine, and we track it all, what's happening. And what do we use to analyze the process and make sure everything's going well? We use Tableau. So we enable the people who run these pipelines to sit at their desk and look at the pipeline and see, is everything going well? Is there anything we need to be concerned about? Or can I go and get a coffee? The primary use of Tableau is to answer one question. Can I get a coffee? Am I right? Yeah, you're nodding. Nobody uses it for anything else. It's, can I go and get a coffee? And this enables them to see, is our pipeline working? Those instruments, they're very expensive. We need to make sure we're running those 24/7. So we have a dashboard where somebody can look at our entire sequencing fleet and see the red line is now, the dark bar is today, then the next one is tomorrow and the day after. Each of the colored bars is a run working on one of these sequences. So we can look at it and we can see, when is it going to finish? And when it does finish, are we going to have somebody working who can then turn that machine around and get it reloaded again? So we use Tableau to keep tracks on these very expensive machines, making sure that they run 24/7 in the most efficient way possible. And when they don't, we need to be able to identify that really easily. So we use some more advanced chart types, a jump plot. So we can track an individual sample of DNA's progress down our pipeline. Each one of these points is a specific action that happens in the lab. And the height of each of those curves is how long it took to go from that step to that step. And they'll start to stack up. And then you can see these big outliers and think, okay, why was that? All the other steps are quite small, whereas we've just got this big outlier here. How can we identify this? And this enables us to look at hundreds, thousands of these plates going through the system. And the majority of things just go through absolutely fine, so I don't need to worry about those. I can go and get my coffee, but if there's a big peak there, I need to know why. We also use Tableau to do a bit of promotional work. We have a lot of visitors come to our site, and they get shown around the labs. We have these big screens, and we want to showcase what it is we're doing. So I built this one to show how many genomes we sequenced the last week, color-coded by the day. We want to showcase the different types of genomes that we're sequencing. So we use the word cloud. Is it a good visualization? Yes, it is. It does the job. So the biggest species we do is humans. But we do lots of different pathogens with very odd, strange names. And we track the amount of sequence data that we put out. A couple of days ago, we actually passed 4 petabytes of sequence data, and this is up on a big screen. And one of the challenges for this is I had to build it using a running sum because we didn't want any of the visitors coming around and seeing a dip in our output. So this can only get bigger. Okay? So if you take away one thing, the running sum is your friend because you don't see when things go down. Things can only get better. And we send lots of people around the world, so we want to track where are we sending all these visitors. So last year, 1,015 trips all over the world, one of which was mine. And because I monitor the server, I built this dashboard so I can look at all the extracts that are falling over. You know, all these TDs that break. Hopefully, this will now be redundant because Hyper's just going to work and never break. Hopefully. But until we get that, this allows me to have a look at, I can see my passes, I can see my fails. Did it fail just once, as it did that one down the bottom there, that little red cross that you just can't quite see? But the next time it ran fine. And then by night, I do other things. I blog. That's my blog. You can go and read some stuff there. I tweet a bit. You can follow me there. It's great stuff, I promise. I'm also one half of the Tableau Wannabe podcast, the premier podcast devoted to all Tableau matters. You can find us on iTunes and any of your other social media. My co-host is in the audience there, Emily Kuhn. Stand up, Emily. Okay. We're recording live interviews at the conference as well this week, so if you want to relive your conference experience, then subscribe to the podcast so you can hear from some of the executives, some of the background team, some of the developers you're going to see later on after this session. And I also wrote a couple of training courses which you can go to lynda.com or LinkedIn and do. And if you follow that link there, you get free access. I think it might be 30 days access. So try that one out. But you're not here to hear about me. If you are, God help you. So this is about going beyond drag and drop. And it's about calculation functions for the non-programmer. So again, sorry, I'm going to ask you again. Quick show of hands. Who's never written a function or a calculation before? Okay. So who copied and pasted a calculation that they found online before to solve a problem? There we go, you see. There's the hands. Now you know you're in the right session now, you see. Okay? And we've all done it because there's so much good content out there. And you'll find a solution that somebody else has already done, and you just copy and paste it in, and it will fix it, and it will work it. But the thing is, it's better to understand how that actually happens. And if you're not the sort of person that writes calculation functions all the time, maybe you didn't come from a coding background, or you didn't come from a database background, you've never used a lot of these things before. If you have, it works pretty much the same way. So I'm going to try, wait for it, to put the fun back in functions. Okay? That's the level we're going to be at today. Okay? That's it. And what could be more fun than Lego? Who likes Lego? Everybody likes Lego. You see, you don't have to put your hands up for that because everybody likes Lego. Okay? Now, Lego is exactly the same as functions and calculations. Okay? Because Lego is like our data. We have a great big pile of data. It's all different shapes, different colors, and it's all jumbled up. And the first thing we do with our data is we sort it out. We sort it into like-minded colors or like-minded shapes and do all our data prep. And then we separate it into our blue data and our green data. And then we might drag and drop to build some charts. And we'll build some simple charts, and we're happy with that. Okay? And everything is good and brilliant. We're happy. We go and get a coffee. And because it's a Friday, we think, you know, to hell with it, we're going to get a bit of cake as well. Okay? And everything's brilliant, and it's great. And then disaster. We get a phone call. And they need something a little bit more complicated. And then we start to panic. Okay? Now, why do you panic? You realize, I've got to do a calculation. And the reason you panic is because of that. Okay? That's scary. That's scary stuff. A blank screen, I don't know where to go or what to do because it just says it's a calculation. It doesn't tell me to do anything else. So what do I do? Okay? And we run away and we get scared. But think about Lego. Lego isn't scary. We don't get scared with Lego. Lego is very, very simple. Okay? It's a block with a stud on the top that fits in another piece. And it comes in all different shapes and sizes, so you get little bits of Lego. But you can combine small bits of Lego into bigger bits of Lego, and you can build a house out of Lego. This is a genuine house that somebody built out of Lego. It was built up by that man there with the long hair, who's out of Top Gear. But it's a house built out of Lego. And what they did is they took small Lego bricks and built real-size Lego bricks and then built it into a house. So, why can't we do that with functions? We can, it's the same thing. You have a small, single Lego block, which is like a function. Now, a function has three things. It has an input. So you have to put something into a function for it to happen. The function then has some kind of action. It's going to do something to that input, and then you're going to get an output. Okay? Input would be something like this. So our input in this case is the sales. So we're going to take the value of sales, and then the action is going to be the sum. So creating the sum of that value. And we can get slightly bigger functions, such as this one. But it's the same thing. It's still a small piece that we can then chain together. And then we can get lots of different functions. We can combine all of those together. And we can then chain them together. So the input becomes the action, becomes the output, becomes the input, the action, output, and so on, and so on, and so on, and so on, until we get something like that. And then they become calculations. And they can either be nice and simple, or like this. That's a simple calculation, nice and simple. Or they become great big complicated calculations, like that one. And that looks a bit scary because there's lots of different colors, lots of blues and lots of oranges and lots of stuff going on there. So that looks scary to us. But think about it. It's still these little tiny blocks that kind of all fit together. So rather than be scared of it, when we get this blank bit on here, we should embrace it because we can do so much stuff with this. Okay? And we can be happy. So rather than give you a fish, I will teach you to fish. Okay? And you'll be all happy. Okay? I found loads of pictures of Lego. And I thought, I found pictures, I'm going to use them. Okay. So there's at least 5 different ways of creating a calculation in Tableau. Okay? There we go. Okay? So you can go to, under the analysis menu, you can do create calculated field there. You could go to the data pane somewhere. Where's that gone? And do create calculated field there. You could right click and a bit of white blank space. If you had a bit of white blank space, you could do it there as well, which I could probably do with that there. Create calculated field. You could just type in there and do a calculation. Okay, so there's lots of different ways you can do a calculation, but they all work in pretty much the same way. Okay? So I'm going to take you through some of the different functions, some of the different function families, and kind of try and explain them to you and see how they all fit together and how they work. So you can go away and you can use them to build some of these calculations up. Okay? So the first one is aggregate functions. So, what's an aggregate function? So Tableau has this real need to aggregate data. Okay, it's the only thing it ever wants to do is aggregate data. I must aggregate the data. I must aggregate it, aggregate it. That's all it will ever do. So even if you don't think you've ever written a function of calculation before, you have. You just didn't know you did it. Okay? Because as soon as you put anything on the row or column, you get that sum function in there. I didn't tell it to do a sum function in there. It's done it itself. Look, this is actually a calculation now. It's got that function name in. I didn't tell it to do that. So even without knowing it, I just created a calculation. So Tableau is doing it for you in the background. So if you thought you never knew how to do function calculations, you in fact did know how to do function calculations. So aggregate functions are things like sum and average that you're used to using, but they are just a very simple function and calculation. So the next one I was going to look at are number calculations. So these are functions that you use on numbers. So the first one is ceiling. Okay? I'm going to make you guess the rest of these as we go along. That's the kind of thing you're going to have to work with, okay? So there's ceiling and there's floor, okay? So what's ceiling and floor? Why are they useful? Well, what does ceiling and floor do? So if we've got these values here, so we've got some order IDs and we've got our sales and we've got this sort of number here that's, we want to round this up or round this down. And we can use ceiling and floor to do that for us. So at the moment, that's just the value of sales. But if I do the floor and apply that, it's now rounded it down to the nearest whole number. Or, if I wanted to round it up to the next number, I could use the ceiling. And that 160 at the top now becomes 162. Along with ceiling and floor, you have round. If you want a little bit more control over it, you can then say I want to do the rounding. Now in this case, remember we said we always need an input. We need 2 bits of information. We need 2 inputs. We need to know the actual thing we want to round up, and then how many decimal places to round it up to. So we could say 1, and now that's rounded it up to 1 decimal place. So that where that was 0.08 now becomes 0.1. So those are very simple number functions. What's this function? Any ideas? Who wants to make a guess? Sine. It's not hard. There's no tricks. Say what you see. Sine. So what does sine do? Well, let's have a look. So we've got some profit values here, and we've got some positive, and we've got some negative stuff. And we'd like to be able to maybe color them by whether they're profitable or non-profitable. How can we go around doing that? We could write a calculation to say, if it's profitable, then do this, or if it's do that. There's a simple way of doing it is we can use sine. So what we could do is we could edit this. And at the moment, we're looking at, so if I calculate the sine of profit, what that's going to do is, and what sine does is if it's negative, it returns the value 1, and if it's positive, if it's negative, it returns the value -1. If it's positive, it returns the value 1. So we don't have to do any calculation, say, is it above this, below this, greater than, less than? Sine just says, if it's one way, it's this, if it's one way, it's the other. It's a really quick way of just saying, is this negative, is this positive? Which you can then use in a calculation. You can put it on the color shelf, you can use it anywhere that you like. What's that one? Any guesses? That's a Zen garden. So it's, Zn is the function. If you can find a better picture in Lego for that, okay. What's the Zn function? Who's ever used that before? Okay, so this is a real-life example that actually happened in real life, actually really. Okay? So I'd written a dashboard that allowed the managers to look at all of the employees and look at how much sick day they'd taken. And I showed the number of days in the bar, and then I put an average down to say, this is the average amount of days that the team has had off. And I published this, and all was well, and I went and got a coffee. And I got an email back from one of the managers saying, I don't think that's right. My team hasn't taken that much time off. And I said, well, you know, Tableau doesn't lie. It must be right. And it turns out he was right. Because if we look at this column here, we can see that David down here hasn't actually taken any days sick. What a healthy individual he is. So this average of 7.4 isn't taken into account that he hasn't had any days off, because what it's doing is it's not including that as part of the calculation. And if you look down at the bottom, we have our 10 rows. The total number of days is 67. So you know the average is going to be 6.7. Well done. That's not bad for an afternoon in Vegas. Very good. So we can use the Zn function. What the Zn function does is it replaces null with 0. So if we just wrap the sickness days in that function. Now, what happened there is we have a tiny little bar now on 0, and because there are now 10 records, the calculation works out correctly, and the average is actually correct. So if you've ever got any data where there's the possibility where it might be empty and give you null, and you're going to use the fact that you have a set number as part of a calculation, play it safe and wrap the entire lot round in Zn. If it isn't null, it's not going to hurt, but if it is, you'll get 0 back. Okay? So the next family of calculations are string. So you're tuned into my wavelength now. Thank you for that. Okay. Another show of hands. Who has to work with data that has been inputted from a free text field? Who has users that can spell correctly all the time? They can't do it. It's impossible. Okay? You'd think scientists might be able to spell the organism they're working on, wouldn't you? No. See all these big words? You'd imagine they could get those wrong, wouldn't you? You'd be surprised at how many different spellings you can get. We have uppercase, we have lowercase, we have underscores, we have all sorts. So anytime you get string data in, it's probably come from a free text field, and it's going to be horrific. So how can we get around this? Well, there's a couple of functions we can use. We can trim some of the data off. So trim is a simple function. It will trim white space. rtrim will trim it from the right of the string. Ltrim will trim it from the left. There's two other functions that are quite useful. Any ideas? Upper and lower. So crane goes up and down. Again, if you can find better, tweet me and let me know. So upper and lower, it's really easy. We'll create a calculation based on the category, and we just say upper in the string, and everything is in uppercase. Or if I did lower, everything would be in lowercase. So it's quite useful if people are unable to type things in correctly. Now, why might upper and lowercase be useful? Well, when we combine these with another function, it enables us to search text fields. So the next function is contains. You're going to get tired of groaning. Okay? So contains is a really useful string function that lets you search through a string. So this one here, we've got our customer, and we've got a little function here, a little calculation that says the customer name equals the name to search for. So the name to search for is a parameter, and we get this little text box. So that calculation is going to take whatever we put in the search box, compare it to the customer name, and if it matches, it will give us true, and it says, effectively, we found that name. Okay? That's good. So we could then take that found the name, we could put it onto color, and now we could search for a name. So let's look for Alan Barnes. Let's see. Okay. And it doesn't find him. Why doesn't it find him? Because we haven't got the case right. So, if you're ever doing this type of calculation where you're comparing two strings, always spell it correctly. First, upper. You wrap both sides in an upper, and now it will find it. So it doesn't matter what your user has inputted in. They could put it all in uppercase, lowercase, a mixture of each one, whatever they like. It's always going to match the input, because the first thing that's going to happen is it's going to convert both of the same case and then do the comparison. Never rely on a user inputting the right bit of information into your database. So that's okay if we want to search the entire string. But I said about contains. So let's do contains instead. So contains says, does this string contain this substring? So in our example here, we want to say, does the customer name contain the value of the name to search for? And now, we're not searching for an exact match. We're saying, does this appear anywhere within that list? So it's picked up these ones here where it started with Alan. But if I took, we just look for Al. There's a few others in there. That's got Al in the name there as well. Now, if we really want it to be secure, what would we put around both? Upper or lower. So you're learning. That's two things you've learned already. So the other two string functions, find and replace. These work pretty similarly, but find and replace is quite useful. So what about if we wanted to find a particular string? So in here we've got a parameter of a string to find and a parameter of a string to replace. So I want to take all the Allens and rename them to Donald. I don't know why we'd want to do that. I mean, there might be a use case for doing that. There might not be. So now, if we look for Adam, replace. Oh dear, that's wrong. So we can use the replace function. And the replace function says, take the string, so the string that we want to find, the value that we want to change, and then take the parameter of the thing we want to find and the bit we want to replace it with. So in this case, find every instance of Adam and change it round to Donald. So what we should have on here, oh dear, that's not right. So let's try and replace in all of those Allens to become all these ones down here are now called Donald. Again, there might be a use case where all the Allens in your company want to be known as Donald. Maybe they do, maybe they don't. But it works for everything, not just those two values, okay? So that's quite useful for cleaning up data. What's that one? Split. No Lego men were hurt in the making of this talk. So a split function. How does that work? Well, split will take any string and then split it into component parts. And what we can do is, again, we can say we want to split. Split? Maybe we do want to split, I don't know. So we want to split the order ID. And then we want to tell it, what do we use to split it up by? Now, in this case, we might want to split it on the hyphen, and we might just want the second part of that, or maybe we want the third part of it. Maybe we want to split it on the number 1 in this case, and get the split on there. So there's an automatic split, and there's a custom split you can do just by right-clicking on a particular value. So we can do splits and custom splits in there. But the actual function splitter gives us much more control over what the delimiter we're using, which section we want to do, and, as I said before, you can take the input of one function and make it the output, input, output, input. So we could chain all these splits together. So if you had a really complicated string, and just piece by piece, you could split it down and down and down to get the individual piece that you want out of it. The next function family, wine. I don't think there is a wine function. It'd be good though, wouldn't it? Should be a wine function. Go to the ideas forum and demand a wine function. These are dates. Such a romantic crowd, clearly, that you can't recognize a date when you see one. Your loved ones must be really missing you this week. Who likes working with dates? You liars. Nobody likes working with dates. They're horrible. There's so many different formats, so many different things to do. So date pars. How many times have you pulled in some data and Tableau hasn't been able to work out what the particular date format is? Everybody done that? Every single day. So Tableau has improved things. So now, a lot of the time, if you pull it in and you ask for it to be changed into a date, it will actually do it. And in this case, it did. It recognized that format and was able to do it. Brilliant. Let's go and get a coffee. But other times, you might get a date format like this. And what happens if we try and change this one to be a date and time? Didn't like that. Didn't like that at all. So, this is the function that it tried to create to try and figure out what this strange format was, but it didn't get it right. So the date parse function takes the date field and then applies a format to it. Now the correct format for this particular example is this one here. Oh, that's not. Thank you, Sam. So for any string of text you get, if Tableau can't work it out, you can do it instead because we have this date parse function. And we say, we know that the correct way of doing a long month is 3 capital M's followed by the D, followed by the Y, followed by that. And it doesn't matter how complicated it is, you can figure that out and write the correct function for it. So that was a fairly long one. What about this one? That's a real format that I've seen somewhere, and that's a pretty tricky one for Tableau to work out as well. But we know how to do it, don't we? We can use date parse. And we can give it our format. And it works. So no matter what horrible data you have to connect to, you can always get a date out of there. With enough letters that you throw at it, you'll get there in the end. Wouldn't it be lovely if we just standardized on dates? So date name and date part, again, quite useful ones. So date name. So date name works on a date, and it's asked you for the date part. So what part of the date do you want to know? So maybe we want to know, what day is that? So we then get told it's that day. Or maybe we want to know that's the day of the month. Well, what month was that for? It's just that month. So for any date that we've got, we can just get the actual bit of the date we're interested in. Maybe we want to know the month. Maybe we just want to know the year. It'd be lovely if it knew decades, wouldn't it? Who would like decades as a date function? Century. Nobody has old data. You're such a young country. Date diff. I don't know what it's got to do with Big Ben, but it's a clock, it's time. So date diff is a way to calculate durations. And a really good use of these is Gantt chart. Who likes Gantt charts? Who has a manager that likes Gantt charts? Who's got a product manager that loves Gantt charts? There we go. So we can create Gantt charts really easily. So we have our orders, we have the order date, we have all of our orders down here, but we need the duration. How do we calculate the duration? Well, bless you. We can use date diff. And date diff says, take the start date, take the end date, and calculate how many of the date parts there are between them. We know about date parts, we just saw those. So we could say how many days between the order date and the ship date. And now we get our value, and we can pop it on size. Now we have all of the bars are sized by the number of days between the start date and the end date. Generally, I always get those the wrong way around and have negative dates, numbers, time. Now be honest, how many other people do that? Well done on your honesty. You, sir, are a liar. I know you do. So logic functions. Logic functions. So there's two types of logic functions. There's case, and there's if. Again, you find a Lego if, you're doing well. It was at this point where I realized the Lego metaphor kind of ran its course. But by that point, you're committed. What can you do? You know, it happens. You get married and then, you know. So the case function. So logic is when you start to chain together these ideas of if something is this, then do this. If something does this, then do that. When something is this value, then do something else on here. So, if. The trouble with doing if is that it doesn't prompt us to do anything else because the world is our oyster. We can say if anything is true. So we could say simply if the sum of sales is greater than 600,000, maybe. And if we've written it correctly, there we go. So if a certain condition is met, then use this value. Otherwise, do this value. But if lets us add more than one condition together. So you could chain them together. You could say, if this is true, and this is true, and this is true, then do this. Otherwise, do this. Or you can do if, else if. So you could say, else if this is true, then do this. Else if this is true, do this. And this is where you get some of the really complicated calculations come out. But it's still simple. One function into the next function, into the next function, into the next function. Okay. Then there's a secret function. Who knows the secret function? Random. Has anybody used random before? You are random, sir. So the random function in Tableau is an undocumented function. That's why it's secret. But it's really useful in this kind of scenario. So in this case here, we've got all of our individual sales across different regions, and we're doing this sort of distribution. And the thing is, I can't really see too much detail. Now, I could change the transparency and make it a little bit fainter, and I can kind of see through some of the data points, but it still doesn't give me a clear picture of what's going on. So we can use the random function, and we can do some jittering. So we just do random, and random doesn't need an input. And now we have a jitter. And if we put this on here, what Tableau does is it applies the random function. If you do average, it evens it out a little bit more. And it applies that. So each of those data points now has another value called random, called jitter rather, which is a random number. And it then just smears it all out. So rather than being all stacked on top of one another, you can see all the individual marks underneath. It's quite cool, isn't it? I like that one. So those are all kind of textbook examples. So what about in the real world? Where do these actually come? So this one here that I showed you before, this is looking at all of the data that we've had off our sequencing machines since we first got the fleet in. And this is looking at the running sums. It's not this every monthly data, it's the running total in there. So these are just a function. It's a calculation of the sum of the data divided by a very big number, because I want to talk about it in terms of petabases rather. And then we're looking at the sum of this, and then we're then taking the running sum of that function. So the input is the Plex Q20 yield, the function is the sum, and then the other function is the running sum, and it all combines together to produce this that can only ever get better. So when our visitors wander around, they never see that we do anything wrong at all. So this one that was looking at the overview of all of our labs, how are they all doing? And this uses some calculations to look at how long has something been waiting at one of these steps. So that's using the date diff calculation. How many days between it arriving in this inbox, so what date did it arrive in the cluster inbox compared to today? The day function gives you today right now. How many days between those two dates? It color codes it. So as things get older and get staler, they go from green to orange to red, and then somebody can pick that up. And this one, it's got lots of date calculations in here. So we have one calculation for the reference line of just today. So the today function would give us today's date, which we can then use as a reference line. And then I've got the colored bars. So I've got today plus 1, today plus 2, plus 3. And we can then piece these all together. But the length of these bars, so when the run starts and when the run finishes, how does Tableau know that? Well, each one of these runs for a certain number of cycles. So Tableau knows how many cycles it's got to do. Every 15 minutes, a query runs to go around each of these instruments to say, what cycle are you on, and how many have you got to go? So we have a current cycle count, and then we have this complication, this in here, where we say, okay, well, what's the estimated run length? The estimated total run length is the start date and the estimated finishing time. Well, what's the estimated finishing time? That's based off the fact that we know how many cycles it's done, how many cycles we've got to do, how many we've got left to do. So every time this data gets refreshed, Tableau is redoing all those date diff calculations. Now this jump plot here, which answered so many questions I've not been able to do before, has lots and lots of calculations and maths. And it looks like that, and it looks like that. You remember that cut and paste keyboard? That was that. I wouldn't be able to write it, but I can kind of understand what it's doing, just about-ish. There was a little bit of random pressing until I got it right and it worked, but the idea was there. So cutting and pasting isn't bad. It's a shortcut. But you still need to be able to understand that one function goes to another function, how these kind of all fit together. That's some real-world examples. Now, hopefully, that's kind of opened your eyes a little bit into the fun world of functions and calculations. Because there's going to be a time when you're going to have to write some of these yourself. And you want to be happy about doing it, rather than be scared about it. And then everybody can know the true joy of calculations. Thank you. Any questions? Yes, sir.
So for the random,
Yes.
random like we geocode doctors. They all say they are at the hospital. So we have 30 doctors at a hospital. Will the random functions spread them in a circle around that area?
I'm going to say no, because I don't know how the random function works.
Somebody posted like really complicated things, like Sarah like had a jitters and all that. But I didn't know if the random was.
It might be able to. I suspect the fact that the random function is undocumented is probably not a good reason to trust it for something specific like that. Yes?
You did a ceiling and floor calculation.
Yeah.
Was the six number down on the right, or it didn't just go up or down one? So it went from 281.5 to 285?
Well, just when did the floor and ceiling function, one of the numbers kind of jumped, instead of going up, it jumped up by 5. Why was that? I don't know. Sorry? Aggregation is the answer to that one there. Yes. Yes, because it was looking at the order ID, so there's more than one in there. So even though you're doing the rounding down, because it's doing aggregation in the background, it would have aggregated it up. Yes?
What's the difference between if and I-if? That's how you had the I-if.
If and I-if. I-if is a specific case of if. It's if it is null.
If it evaluates as true, then you tell it what to do, and if it evaluates as false, it also tells you what to do. So it's just a way of combining those into one command.
You could use if anything else typically use it for a single test.
So rather than having, if you just know that it's, I only want to test this one specific thing of saying, if this, then you can't chain it in and have if this, else this, if this. It's just, if this is true, bang. If this is not, it's a specific use case for that. Yes?
The ZN function, I
It depends. It might be. I don't know. I just know that in that specific case, it tripped me up on that one there, where because I had those null values in there, because it wasn't taking the actual nulls into account when it's doing the calculation, because it doesn't add up the fact that it's 0. It wasn't counting up the correct number to do the average calculation on. I was surprised because I'd never come across it. It was only because a third party who actually looked at it and he knew his numbers said this isn't right. So I'm going to check a lot more of mine now as well. Yeah. Not really. I think I have seen some tests done on it, and there's, under maybe some circumstances, but generally, no. It's more about, because with if, you can join several different conditions together. So you can say, if country is this, and this, then do this, whereas case is, in the case of this, when this value, then do this, when this value, do this. Some people just find it easier to write one than the other. I tend to use case more often just because I find it easier to write the syntax rather than if, because it just looks neater sometimes. But generally, the performance is going to be identical either way. Yes?
For the contains function, is there a do not contains way of doing it? Or?
Yeah. So you could do contains equals false. So you'd have to do, yes, you probably can. I'd have to think about it. Testing for false and lack of something is quite tricky in general. It's a lot easier to test that something is present rather than something isn't present. Well, thank you. Go to devs on stage.